Hello, flatties and globers. Yes, it's Critical Think from Down Under, and in this video we'll be looking at inferior mirages and observations over a curve. Okay, here we go. I'm just going to summarize a little here. So we've had claims by flatties that we do not observe curvature when a ship goes over the curve. And there are always a number of excuses, and one of them which involves the inferior mirage. Now, we've been shown a lot of pictures and videos of ships, for example, with an inferior mirage, and the argument has been something like that the mirage hides the ship. But we'll examine that a little bit more closely and with a critical eye, and you should watch the whole thing and listen to the argument before making some dumb comment. So let's think about what is it, and it's been called the reflection layer because you see a reflection, mirror layer, mirrored zone, refraction layer, and of course inferior mirage. So, and then what does it look like over water? So here's a picture I took, and you can see that there is a mirror line. You can just see the middle section of the boat, and that's around about where the mirror line is. So you can see part of the boat and then a section of mirrored water under that. Well, the mirror zone, I'm just going to call it that at the moment. So here's another shot that is low over water because it's severely distorted by air movement, and there is a mirror layer, and again you can see the waves are not quite straight, and the mirroring leaves a jagged edge with little bits in the air and everything there. Here's another shot of an island from a long way away, and you can see the mirror line along there with the sailing ship to the right and the obvious mirror on the land near the water. So what explanation do we have from the flatties? So here's one. It says that Wide Awake says it pulls objects down into its own reflection and hides it. Now, I'm not sure how that's supposed to work, and sure, that's a very interesting explanation. There seems to be no other explanation other than some mirror layer pulls objects down. Now, I'm not sure how it does that because there's no science for that. So I'm going to play a little bit of video here now. It's one of Ranty's videos, and in this case there is an inversion layer and a ship and some changes in height. So I'll just play that for a little bit.
And as you can see, the boat is sitting on the horizon and is fully visible. In this next image, I lowered my elevation as I walked down the beach, and I dropped to 7.3 meters. And what you can see here is some mirroring effects taking place at the horizon. The top of the boat is still visible and intact. It is not being affected by any mirroring. However, the lower parts of the boat clearly are suffering some form of mirroring on the horizon. So if I put a straight line in, you will see the mirroring effect at the horizon.
Well, there's no argument with that so far.
What is happening here is that the hard horizon, i.e. the sea beneath, is sitting beneath a layer of what I would say is dirty air. and that dirty air is causing an optical illusion which is reflecting the top part of the boat onto that dirty air. I would like you to keep your eyes on the horizon and the two masts on the boat. As my elevation drops, what you see happening is the hard horizon stays as a hard horizon. The middle part and lower part of the boat start to disappear. However, the masts of the boat stay a consistent height above the actual hard horizon. In fact, as we get to the lowest elevation, you'll see that the masts actually get a little bit longer, and this would be consistent with the change in elevation, as you would now be looking up towards the masts, and these masts would extend in length as you look at them.
Where is the science for that? The masts will appear longer because you're viewing them from a lower elevation. Oh my goodness, the flatties just love to tell us that we don't show any science, but it's okay for them. They don't need any science, but they demand science from us. Oh man, and I'm calling bollocks on this one. So let's look a little bit about what's going on here. He started out at 12 roughly meters, going down to 0.2, which is a drop of roughly 12 meters. So this is the sort of thing we're looking at. Now, I don't know how far that ship is really, but seeing as it is over the horizon, according to his elevation, I'm going to just take a rough guess at 6.5 kilometers. Now, it could be a little bit more, maybe a little bit less, but the numbers are of the order of several kilometers, and he's changing his elevation by 12 meters. So, here's two things here. First of all, how much difference in viewing angle is that? And second of all, what is the science to make those masts look longer? The answer, of course, is there is no science to make them look longer, but we'll look at this anyway. So I've made this triangle which says in a drop of 12 meters over 6,500 meters is going to give us a change in the angle of 0.106 degrees. Now, if you think you can detect that change, good on you. And so I've calculated a little bit differently here too. So I don't know how tall that ship is. I'm just saying 40 meters. And the ship's 40 meters high. It's roughly 6,500 meters away. So the angle of elevation is 0.353 degrees. Okay, now if we change the height that we're at, so that instead of the mast being 40 meters above us, it's only 28 meters above us because we've changed elevation by 12 meters. The change in the angle is now 0.247 degrees, and from 353, a change in the angle of about 0.106 by the looks of that. So, are you going to notice a change in the angle of 0.106? Certainly not enough to make those masts extend, even if they did extend. But that's such a tiny, tiny difference. Now, I'm going to test this theory out about things getting longer as you look at them from a lower elevation. Now, I've got a picture of a building here. I'm across the street from the building. I'm going to pretend that this building is a ship, and let's just make this lower floor the mast of the ship. So from across the street, it looks that high. Then I can get down under the building, and the length is now this length here. Are you seeing it yet? And then here now, obviously, I've come up, lowered my elevation angle. So to the extreme, you can't get much lower than that. And the actual window there, you can tell there it's not really elongated. And I've put these together, these views. So here's the long version of it. As you go down in elevation with reference to the building, then it's come smaller, and as you get down in elevation some more, it comes smaller still. So the whole idea that something looks longer if you go down in elevation appears to be total bollocks. So why would the mass appear longer? Well, you know that layer of dirty air you're talking about, obviously causing some distortion and making the mass seem elongated. It has nothing to do with the viewing angle. Oh. So we've drawn some lines on some images that are distorted and comparing one with the other. And of course, he gets the answer he wants.
So boats do not go over the horizon. They simply merge in to the horizon. The mirroring effect takes place above the hard horizon, and the entirety of the boat is still there. It's just that we cannot, with our eyes and our optics, peer through the dirty air that causes the mirroring effect.
So what he's saying is that the layer of dirty air is just hiding a part of the ship, and when you go down, the layer of dirty air is just hiding more of the ship. And he's put these lines here and made these images look like that the whole ship is still under there. So you've got the whole ship, and if you draw a line up there, that's the layer of dirty air hiding the rest of the ship. And that is, it looks convincing enough, except for the fact that the elongation of the mass, which means that the image is elongated, which means you cannot compare this image with this image unless you scale them to be the same, which is what I've done with, I've taken all these images and I've taken some points which I could identify on the images as best as I could. So we've got the top of the mast, and there was that something else, some protrusion near the top of the mast, the top of the cabin there, or whatever it is. I mean, I have to say, these pictures are very poor quality. So it's very difficult to actually come to a firm conclusion on these very poor quality pictures. But we'll proceed with this. I proceeded with this. So I've drawn a line through that part which is always visible, and it's the part where this cabin curves around there. So I've taken a sample of those images and scaled them vertically to match each other. So these parts on the superstructure that match up. That's the only fair comparison you can do. You cannot compare a stretched image with one that is not stretched. That is just not a scientific method, and it is in fact cheating. So when you do this, you can notice that his so-called hard horizon is not at the same level as the picture for the original boat, and as you go down, the water level is actually rising. So his own photos debunk his own argument. So how about that, folks? And another thing I wanted to point out is, you cannot compare the quality of those photos with the quality of this one. See, notice how the horizon is actually much more crisp, and there's no funny business going on near the horizon. So, there's no refraction layer to speak of, no mirroring layer to speak of. There is a small amount of elongation, and we mentioned elongation. And so how can the ship hide behind a refraction layer that's not there? There's only one thing there that I can see, and that's water forming a curve. Now, I've got some other pictures of my own that I've used. I've done a similar thing with these ones. There is a small mirror layer on the bottom of the ship there. You can see that. And this one, the reflection there. So here's another case where there is a refraction layer, dirty air, whatever you like to call it. And let's just see how much of the ship it's hiding here. That much. Oh, there's a lot more. That's the refraction layer. Because I'm zoomed in, there's very little of the ship left as it's going away. And there, just the top of the funnel sticking out, and there's your dirty air. But is that going to conceal a whole ship? Well, I don't think so. And now I'm going to put up a photo that shows my composite photo of my ship. And look at that. It falls well short of concealing the ship. The water just keeps rising. There's no getting away from that. Now this is just the beginning of this. So this is just, I have to continue with this because there's a whole lot more, because I've got to go into the falsity, the falsehood that the dirty air layer is in fact air. And I'll be addressing that in part 2 because this has gone on for a long time, and I understand it's difficult to watch long videos, but it's also very difficult to delve into these things properly, carefully, with some science in there. So it just takes time. I just can't make something up. Okay, well, thanks for watching. Please subscribe. Hit the like button if you like it, and you can hit the not like button if you want to. I'm sure that you will. A lot of flatties will not like this because it's just clear and crisp and really simple demonstration that what you're trying to peddle is rubbish. Thank you.